we will undo the differentiation of trigonometrical functions. Remember, the derivative with respect to x of sine x is cos x. Therefore, integral cos x dx is going to be sine x plus c. In the same time, we can have a composite function. Remember that the derivative with respect to x of sine of ax plus b, where a and b are constants, is cos ax plus b times the derivative of x plus b, which is a. Therefore, integral cos ax plus b dx is sine ax 1 over a sine ax plus b plus c, which c is a real number. The formula itself looks quite simple. However, when we integrate functions of this type, we can also use substitution so that we make our things clear. So practically, instead of kind of guessing or remembering this 1 over a coming in front, if we use substitution, we can think in the following terms. If we want to calculate integral, for example, of cos 2x plus 3 dx, so this is going to be I remember that the derivative is sine is cos, so it's going to be sine of 2x plus 3. But then when I differentiate sine 2x plus 3 chain rule, it's 2 cos 2x plus 3, so I need to divide by 2. So we can treat it in this way, or we can think of it as, I know that integral cos x is sine x, but here I don't have x, I have a composite function, so I'm going to say let u be 2x plus 3. Therefore, du by dx is 2. So du is 2 dx. Replace, so we get integral cos of 2x plus 3 is u. Dx I need to replace x as well, so dx is half du. Half goes in front of the integral, cos u du, which is 1 over 2 sine u plus c, which is 1 over 2 sine of, and now I go and write it in terms of x. See exactly the same answer. In the same way, we have other two formulae for integration coming from the formula of differentiation. Remember, when we differentiate with respect to x, cos x, we get minus sine x. Therefore, integral sine x dx equals minus cos x plus c. Now, anti-chain rule, let's call it anti-chain rule, integral sine of 2x plus 3 dx is minus cos 2x plus 3 over 2. Again, how can we think about this? Either by inspection or saying let u be 2x plus 3. Therefore, du is 2 dx. So we have integral sine of u times dx. dx is a half du. So 1 over 2 integral sine u du. So it's minus 1 over 2 cos u, and u is 2x plus 3 plus c. We see any real number. And the third formula of integration is paired with the following formula for differentiation. the derivative with respect to x of tangent x equals, remember, sec square x. Therefore, integral sec square x dx equals tangent x plus c. The anti-chain rule tells you that integral sec square of ax plus b dx equals tangent ax plus b over a plus c. As you see in your syllabus, when we integrate using the substitution, because this is also hidden substitution even if it's by inspection, we compose only with linear factors. So these are the only factors actually in your syllabus. When we move on, we'll see more complicated functions. And let me give you an example on the other page. Before we move on the next slide, slide number 5, we are going to have a problem beyond the syllabus, which if you want you can skip, but then I would like you to look over slide 6. This is, I repeat, outside the syllabus, but somehow shows the value of integration by substitution, which we are going to use a lot next year. Suppose we try to solve the following integral. Integral sin x times cos of x dx. Wow, scary, right? Let cos x du. Therefore, du by dx equals minus sin x. So, du equals minus sin x dx. And now we see we have here sin x dx, which makes together sin x dx makes together minus du. So my integral becomes integral cos of u, and the rest, the left is minus du. So this one integral minus this is minus, and the integral of cos x is sin x, so this is minus sin u plus c. So now I go and replace this, and this minus sin of u. Remember, u was cos x here. So yes, that's plus c. So it's a quite complicated function to integrate, much beyond the syllabus, but shows the value of integration by substitution. Just please note that sine of cos x is not sin x times cos x. For example, if x equals 10 degrees, you first calculate cos 10 degrees, and then you calculate sine of this answer. One type of integral that they trick you with is integral tan square x. We didn't have any formula with tan square x. But remember, it is related with another formula that we know through a formula 1 plus tangent square x equals sec square x. And now we know how to calculate the integral of sec square x. Therefore, tan square x equals sec square x minus 1. So your integral is integral sec square x minus 1 dx. We know that integral sec square x is tan x. Integral of 1 is x. This method can be also combined with a anti-chain method. See next slide. What if we have integral tan square of 1 minus 5x dx? See, maybe now you can see the value of the substitution, because you cannot solve this integral within one step. So you split it into smaller bits. First will be let u be 1 minus 5x. Therefore, du is minus 5 dx. So your integral becomes integral tangent square of u times dx is minus 1 over 5 du. And now you can use a previous method and write tangent square u as sec square u minus 1. So this gives me minus 1 over 5. Integral of sec square u is tan u minus u plus we set the secant on the outside. So now I go and change back to x. So my answer is minus 1 over 5 brackets tan of 1 minus 5x minus u 1 minus 5x. You can open this bracket if you want.